All right, so now we're on to parabolas. So this time, of course, we don't use the word center, we use vertex. Vertex is HK. So this H is still paired with X and K with Y. So instead of just X squared equals 4PY, we have X minus H squared equals 4P times Y minus K. So again, it's the squared term tells you where the axis is. So this is a vertical axis, meaning this one opens up or down. And remember, this one is the function because of the x, y. We could solve for y easily. You can get it in terms of x. This one, when the y is the squared term, then it opens right or left. And so the axis is horizontal instead. I would prefer to write it like this, but you could also write it like this, of course. So with these formulas here, again, it's just use counting, and it's easier than memorizing these extra formulas. I'm not even going to talk about those. I've just put them in there for completion, but it's really easy if you just count. Just count from the vertex, just like you would have counted from the origin before. All right, so now well, of course, the origin was the vertex before, but, that's a different point now. So find the vertex, focus, and directrix of this parabola and sketch the graph. Since the y is the squared term here, then we know this opens right or left. This is our 4p. I should have mentioned, notice that this is in standard form, right? We don't have to do anything with it. We've got our y squared term here, coefficient in front of the x term, which is to the first. So the 4p is equal to 12, which implies p is 3. Because p is positive and the parabola has to open in, cup into the focus, then this opens right. We knew it was right or left because of the y squared term. So our vertex, let's start with that, then we can start graphing. Our vertex is, so be careful, you got to do x term first, 2, -4. So 2, -4. And it opens to the right, so the 3 here is just count 3 units to the right from the vertex. So here's F, here's V, and here's F. And we want to find the coordinates, so that's easy, it's just 5, -4. You can see it on the graph. That's why I say don't worry about remembering this formula. You don't need to do that, just count. All right, there's our focus. Now, the directrix, we count 3 the other direction, and of course that's a line. So the directrix, that's a vertical line, x equals -1. And then sketching the graph, remember from here, if p is 3 from your focus, you want to double that, you get 6. Go up 6, and then down 6. That's the length of the lattice rectum. That's 4p, and your parabola will go through those 2 points so that you get the right width of the parabola. That gives you a really nice graph if you find those 2 points. Okay, let's go on to the next problem, which is not in standard form. So now we have to put it in standard form. So the first thing to decide is, okay, which one is the square term, which is pretty easy to decide because you see an x squared term. So you want the x terms on one side and the y terms on the other. Notice how the way this is written. This is all with x on one side. If there were a y squared term, then we put the y terms on one side and move everything else to the other side. So first I'll isolate x squared plus 6x and move the 4y and 5 over to the other side, so it becomes minus 4y minus 5. That's first. Sorry, the sun is really bright there. I'll try to block it. Okay, so now it's a completing the square problem. If this isn't a 1 here, I would go ahead and divide everything by that, but it is. So we're ready to complete the square. So x squared plus 6x becomes x squared plus 6x plus 6 divided by 2 is 3, and 3 squared is 9. So again, I should have mentioned, I'm completing the square because in the standard form here, I've got a perfect square. So this 9 that I added to this side, I have to add to the other side to balance the equation. Now it's equal to what I started with. Then I factor, because I've got my perfect square that I wanted. And then I've got negative 4y plus 4. And then the last step to get it in this true standard form is to have, well, I'm looking at this one, right? The y inside the parentheses with a coefficient of 1. So whatever the coefficient is here gets factored out of both of these terms. And in this case, it's a negative 4. So I'm going to factor negative 4 out, and I'm left with y minus 1. So if I redistribute it, I'd get back to where I started. Oops, that should be an x. So now this is in standard form. Then, of course, this coefficient helps me find p. For p is negative 4, so p is negative 1. Because that's negative, this opens down. Of course, I should mention, it's either up or down because of the x squared term. P is negative, so this implies this opens down. All right, well, I need to know where is it open to. First, I need the vertex. So what is the vertex? So it's, look at the x term. 3 is the x coordinate. 1 is the y coordinate. Oh, this should have been a plus 3, I'm sorry, because this is a plus 6x. So then that changes the vertex to negative 3. I apologize. So vertex, here, let me make this a little darker. There, that's better. So vertex is negative 1, or negative 3, 1. There's V. Count down 1 unit to get to the focus. So here's F, and we can clearly see the coordinates of the focus, negative 3, 0. If I want 2 more points on the parabola, I'm just going to, because that's 1 unit between the focus and the vertex, I'm just going to count 2 units to the right and to the left of the focus. That gives me 2 more points on my parabola, and I got a nice parabola now. And then the directrix, I just go 1 unit in the opposite direction of the focus and draw a dashed line. There's my directrix, and that would be y equals 2. And we're done. Okay, one last example here. It says a parabola has focus 3, 2, and directrix x equals negative 4. Find the equation of the parabola. So for me, it helps to just draw a little quick sketch. Focus is 3, 2, and directrix is x equals negative 4. That tells me, I know that the vertex has to be halfway between the directrix and the focus, so I can find the vertex now. It's got to be, the y coordinate has to be the same as the focus, because I got to go this way. And there are, let's see, this is 4 units, and this is 3 units, so there's 7 units in between the focus and the directrix. So P would have to be 7 over 2, halfway in between. Now, I also need to decide the sign of P. Sorry, I'm thinking about 2 things at once here. Give me a second. go back to that, the sine of p, but because I know the vertex has to be, so that's 3.5, sorry, 3.5 units away, so that, I'll write the coordinates in a second. This has to open into the focus, so I know p is positive. That's what I wanted to say. If the directrix were over here and the focus were over here, then p would be negative instead of positive. So we know p equals positive 7/2 or positive 3.5, whatever you want to write it. The vertex, the coordinates here then, I know the y coordinate has to be the same as the focus. The x coordinate, since this is 3.5 units back, would be negative 1/2, comma, 2. So I got to use the orientation to figure these things out. That's the point here in the problem. Because it opens to the right, then I know I've got the form y minus k squared equals 4p times x minus h. So I know the h and k, and I know p, so I can just plug this all in, and my answer, y minus 2 squared equals 4 times p is 7/2 times x minus negative 1/2 will become plus 1/2. So y minus 2 squared equals 2 times 7 is excuse me, 14 times x plus 1/2. There's my equation in standard form. All right, so you really, I mean, you could picture this in your head maybe without trying the graph here, but I would recommend putting it down and making sure that you're clear about which of the two equations this would be, right? If the directrix were y equals negative 4, then it would have to be an x over here. And of course, that would flip where the coordinates go and everything. Excuse me. All right, so on the back page, I just talk a little bit more about recognizing which conic you have if the squares are expanded, so it's in expanded or general form, if you will. So the thing to look at are the a's and b's on the coefficients of the x squared terms and the y squared terms. If those are equal, and of course not equal to 0, then you have a circle. If they're the same number, you can just divide everything by that number, and you got x squared and y squared both have a coefficient of 1, so it's a circle. If they are not equal and have the same sign, we talked about that, then we have an ellipse. And then if they have opposite signs, then it's a hyperbola. If one of these is missing, so there's like no x squared term, but there is a y squared term, or there's no y squared term, or what did I say? Oh, I think I said that right. And but there's an x squared term but no y squared term, then it's a parabola. Okay, so those things are, that's how you're going to recognize which one you have. And the parentheses, except for degenerate things like, well, maybe that's, if you have, for example, x squared plus y squared equals 0, right? That's really just a point. It's not really a circle. So that's not actually a conic then. That's what I mean by that. All right, you can let me know if you have any questions about that. But again, it's not so much about memorizing all those formulas as it is remembering the relationships, and then you can just count to find all those important parts. Makes it a lot easier.